Well, good morning, everyone. Thank you for joining us for today's webinar, Healthcare at a Crossroads, a new solution to an old problem. This is Steve Mann. I'm the Vice President of Sales at Concept Searching and one of your co-hosts for today's webinar. Just a little bit about me. I've been in the managed metadata space for several years now and currently spend most of my time on business development and account management. So joining me is Steve Smith, Senior Consultant at CDH, one of our gold certified partners. Steve, if you can, please tell everyone a bit about yourself.
Hello, everyone. As Steve said, I'm kind of a veteran specialist in enterprise search and taxonomy, and I've also spent over 10 years in clinical informatics, and was one of the founding members of the HL7 standard back in the 90s and authored several of the HL7 standard ADT and orders and some other of the items on the HL7 standard back in version 1. So thank you, and I'll be doing a demonstration later in the presentation.
Okay, thanks, Steve. Okay, everyone, this is the agenda that we'd like to follow for today, but first, just a few housekeeping details. We will be recording this webinar, and we will send all registrants a link to the recording, as well as a link to the presentation. In the presentation, if I could just digress for a second, there's a lot of information on each of the slides, and so just maybe don't get so caught up in trying to take notes, because you are going to be getting a copy. And really, the idea of the presentation is that can be a standalone reference material moving forward to any folks you want to share with who don't have an opportunity to listen to the webinar. Okay, and should you have any questions during the webinar, please type them into the chat box. If we cannot answer them today, we will be sure to follow up with a response within the next few days. Okay, so back to our agenda. We always start our webinars with a bit about concept searching, who we are, what we do. We're going to segue over to content management challenges unique to healthcare. Then review a recommended framework for managing content effectively. We'll highlight some specific healthcare use cases before I turn it over to Steve Smith, who will run through an in-depth demonstration showing how CDH has leveraged the concept searching technology to deliver a robust content intelligence solution. All right, for those of you that may not know who concept searching is, we've been in business since 2002, first to market with a solution to automatically apply semantic metadata, and we're still the only solution in the market with a fully integrated statistical multi-term auto-classification platform, which we use to deliver metadata-driven search and governance solutions. We've been a managed Microsoft partner since 2008, and we're one of only 11 search partners worldwide who's a Microsoft Business Critical SharePoint Program partner. Our product platforms deliver metadata-driven search and governance solutions for all versions of SharePoint on-premise from 2007 on, as well as all versions of SharePoint Online. We offer full product support in the form of both a farm solution and a provider-hosted add-in. So what we do is metadata generation, auto-classification, taxonomy, and term store management. And as mentioned, we integrate with all versions of SharePoint on-premise, in the cloud, or a hybrid environment. Now, our platform is not a web part, but an infrastructure platform that offers the flexibility to access content in non-SharePoint platforms and repositories. Our contention is that once you're able to automate the process of generating metadata and tagging your content with metadata, is that metadata can be used for a whole host of very impactful endeavors, including data privacy, records management, compliance, text analytics, which we refer to collectively as intelligent metadata-enabled solutions. So I think there's little dispute that metadata can be very helpful to organizations to improve findability. I think where the discord takes place is how to apply that metadata. And most organizations, probably because there's little upfront cost associated with it, they like to foist the responsibility of tagging content to its end users, and that just tends to be really the bane of most organizations' existence. And for some of the reasons that you see listed here, manual tagging typically leads to failure. All right, so if you only remember one thing at the end of the day about concept searching, please remember our compound term processing engine. Really think it's one of our key differentiators, still unique in the industry. And essentially what the compound term processing engine does, it allows for us to search for multi-word phrases and terms, which we feel are much more impactful than search tools that rely on keyword search. So to illustrate that, we have this example here of triple heart bypass. And first, I'll say that when we think about search, and you think about what knowledge workers need, what they need is to be able to identify content in the context of what they're seeking. And the fundamental problem with search solutions is that they're based on an index of single words. Yet oftentimes queries are expressed in short patterns of words and not single words in isolation, which can be highly ambiguous. So really, just to show how ambiguous, we have this example here. Now when you all look at triple heart bypass, I'm just guessing consciously or subconsciously you think, aha, open heart surgery. But when you take each of those words individually, break them up as we've done here, you can see that those words individually have much different meaning than the multi-word phrase. So if you are a search tool that is relying on keywords, that means in this instance, we'd identify all the documents that contain the words triple, heart, and bypass, instead of documents that contain the concept of triple heart bypass. And there's going to be a lot of noise in the search results. And I think folks are, a bit spoiled these days, so that, not only do they expect, if they get 12 pages of search results, they're just going to move on. And, people not only want to see the search results on page 1, but they want to see it in the upper half or even upper third, of page 1. So with the compound term processing, we're able to identify, the concept of triple heart bypass. And since we're able to do that, that means that we're also able to identify other documents that have related concepts, even if they do not contain that exact phrase within the body of text. So some examples here might be coronary surgery, heart attack, or stroke. All right, when it comes to healthcare, the healthcare industry, probably no surprise to you all here, is unique. And one of the major challenges is the inability to access and leverage unstructured information. So even for quote unquote big data, the vendors convert the text to database fields, and in that process, they often lose valuable information that can help improve patient care and decision making, as well as, the possibility to gain insight on trends or specific patient issues. Just a bit of a statistic for you. Health Story Project estimates that some 1.2 billion clinical documents are produced in the US each year. And about 60% of those contain valuable patient care information trapped, so to speak, in an unstructured format. So this could include images, graphics, emails, what have you. In addition, I have an issue around the erosion of the clinical value of information. We have 5 million medical notes created daily. Again, the 2 billion notes annually, which is all in text. As a result, I think you have reliability of data is difficult. Data can often be entered erroneously. If you even think of yourself when you've been in the role of a patient, and oftentimes you go to a doctor for the first time, they give you like a 5-page patient history to fill out. I know, speaking for myself, maybe sometimes you're a little distracted, you're a little stressed out. Maybe you don't fill it out as completely as you do. Or maybe you do, and maybe the person who enters it in doesn't, enter it in correctly. I think just an example there of how there are some different points that information can be entered in incorrectly. And then there's also an issue of evidence-based practice, that practitioners can only access information that's in the database. Again, some things that are often maybe of an interpretive nature, are not, correctly captured. And then I think something else we've noted in the healthcare industry is a relative lack of IT investment. It seems in healthcare we've noted less than 6% of budget is devoted to IT versus, let's just say, compared to the U.S. government, on average, government agencies devote 16% of their budget to IT. So another challenge there. And with all these challenges, there is still definitely a mandate for every healthcare organization to deliver value-based care and to improve patient outcomes. All right, what Steve Smith is going to demonstrate is the integration of all your applications that you are authorized to use from a single interface. It's not just putting options on the menu. The unique differentiator in content intelligence is the metadata can be complex, meaning it can represent a concept, topic, or a subject. And the added benefit is identifying related content that you may not have searched for and perhaps would not have found. Within the framework, it's not only unstructured content, but semi-structured content, let's just say, usually forms, and structured data, providing a 360-degree view of relevant content, regardless of type or where it is stored. So this is accomplished through our core technology components and connectors. The applications shown represent the wide range of solutions possible with concept searching. We won't go through these today. More details for all applications are available on our website. So when we talk about where it hurts, so let's talk about, effective content management. And effective content management really starts with search. Once you know where content is, then you can do something about it. So the depth and breadth of the concept searching solution allows healthcare organizations to leverage it in order to meet its diverse needs. So we've summarized 6 use cases on the next 2 slides, and in the interest of time, I will highlight 2, but if you download the deck, you'll have the other use cases as a reference. All right, so the one at the top, implementing hybrid search at a children's hospital. This children's hospital used concept searching to help pre-process content ahead of its migration from file shares to SharePoint Online. As part of that process, it looked to improve knowledge management for its business users and to enforce such information governance initiatives as data security and the protection and management of PHI and other sensitive information. So we're able to support the augmentation of metadata through auto-classification of content, extraction of semantic metadata through statistical correlation for best term analysis, taxonomy refinement, and search. Now I chose this next one with the University Medical Center because this is an instance of an outward-facing website. Using concept searching to benefit patients. So this is one of the top-rated cancer centers in the United States and is using concept classifier for SharePoint on their externally facing website. The current site provided free text speech, which often resulted in too much irrelevant information with little ability to filter out the unwanted results for patients, caregivers, and visitors to the site. So they chose concept searching to auto-classify their website and deliver the ability to provide guided navigation to end users to find specific information, resulting in relevant and precise search results. Concept Taxonomy Manager will also allow the medical center to normalize complex medical terms to make it easier for site visitors to find the information they're seeking without typing in complex medical terms. All right, and at this point, I'm going to pass it over to you, Steve.
All right, thanks, Steve. So what you've heard from a product perspective about taxonomy management and in terms and keyword search and compound word search, and the ingestion of data, okay, it's not just search. We're talking about all of your sources of content, right? So it's your clinical information system, radiology lab, right, pharmacy, and it's all of your document management systems, disparate data sources in one pane of glass. The other thing to note too, and I'm going to show you kind of examples of this, is it's not just the ability to search and find the information, but we can also then allow that information to be visualized, analyzed, and predict outcomes using machine learning, deep learning technology. So we're using the same search index to allow you to do graphing and charting and visualization of the information. And if you want to do kind of deep research, you want to do artificial intelligence, deep learning against the data, again, we're consuming it from a central search repository index. Now, it's important to also know that that search index is augmented with all of the semantic meaning of the data using the concept search platform. So accurate and substantiated data on a secure and scalable platform. So how we do this is, and I'll kind of walk through the slide from the bottom to the top, is on the bottom right, unstructured content. This is all your document management systems. Could be a file share, could be SharePoint, could be Documentum, could be eRoom, could be your social network. If you have internal private social networks or even public social networks, it's all your unstructured content. So think of that as documents and text, right, and images. And on the left at the bottom is all your structured content. So clinical information systems, lab systems, radiology, your ADT system, you know, for admission, discharge, transfer, your billing systems, that's all structured data. We're ingesting both of those up into this white box content intelligence. When we do that, it allows you to do the things that are both on the kind of left, which is search, business intelligence, visualization, analytics, artificial intelligence, and on the right, allows us to use the concept search engine to do single corporate governed nomenclature maps, right? So if you use 5 different terms to mean the same thing, you can put all 5 of the terms in to the concept search engine, and then every single source of information that is ingested into the white box from the bottom is automatically processed with that single common nomenclature map, right? So the taxonomy is applied centrally to that white box content intelligence index. So the semantic meaning of the information is added into the index itself so that it's much more relevant. So let's take a look at what's inside that white box content intelligence. So in the middle, that white box content intelligence is a graph database, a graph data lake of all of the information that we're ingesting in. So again, starting from the bottom, your clinical data, finance data, your clinical documents, all of the content sources go through our external source connector and are ingested into that graph data lake in the middle. Then that graph data lake, if you look on top, the concept search, what they call the Q's engine, is what processes all of that information before it's entered into the data lake and augments it with the additional metadata, right? So it gives the semantic meaning to the data before it writes it down into the data lake, into the index. And then we have connectors that allow you both on the left to connect to all of your visualization tools that you use. So any of the visualization tools that you use today, we can actually output the graph data into the rows and columns, the format that is needed by visualizations and predictive systems. And then on the right, into Azure Machine Learning, any artificial intelligence system that's out there. So if you're a research facility, if you're a teaching hospital, if you have a need in your clinical informatics division to actually do some deep learning analysis against your data, right now your data is so disparate that it's hard for them to use master data management to try to organize disparate data and in a format that's easily ingestible by, an artificial intelligence deep learning system. We can also ingest data from outside. So if you just talk about demographics data, if you want to talk about data that's in the public domain from the CDC, from the National Institute of Health, any of those outside sources can also be brought into that same data lake so that your deep learning can actually learn from a very large set of data, both internal to your organization and external supplied information. So let me actually do a live demonstration, kind of show you some of what we've just talked about. So Steve, if you'd like to give me control, I'll go ahead and show my screen. So just at the very beginning of it, right? A typical search engine, you go in and you search for something and you get a set of results. In this case, we're using Microsoft search system, and I just want to kind of highlight a few things. First thing is, we've talked in this presentation about multiple sources of record. So in this case, I have sources that include lab results, that include SharePoint data, patient data, data from document management systems, medical imaging systems. And you see here the count of the sources. Now, this is a demo lab that we have. I don't have a lot of data loaded, but for our customers, we're talking about hundreds of millions of records, right? So we have some state organizations. They receive of over 1 million transactions a day to the state. So very large sets of data, very large data lake, big data kinds of things. So, but in the demo, I only have a small set of data to kind of operate with. So if I click on medical imaging, for example, I can see that I have results from the various medical imaging systems. If I go back and I look at, kind of all the sources of record again, and I look at lab results or diagnostic results, I get to see the information from those sources. But let's dive in now and let's do a specific search. So just because these patient IDs and the MRNs and the episode encounter numbers are so long, I just kind of pre-typed one. But if I go and do a search for this patient ID, I see that I have 169 lab results for that patient. I have 12 images. I have 4 different diagnostics, but it's for a single patient. Patient's name, Don Johnson. Here's his patient ID. I also see that the patient's race, the gender. I can see some of the lab tests that were performed, some of the lab values, and I can dive in and sort through the specific results. So we're talking about a specific patient across all of their episodes, all their encounters with your facility, and then looking at specific lab results, medical images, so forth. You can also do shaped queries. So if I'm trying to do a query to find out all the patients that had a specific diagnostic code, right? So an ICD-10 code, or if you have an internal code that you use for your diagnostics, I see here that I have several patients that have had this particular diagnostic or admission diagnosis for that patient. So if you click on one of the patients, when you click on a result, it's going to take you to that source system. So if you're using HBO or McKesson or Cerner or whatever the source system is, the result that you see on the search result is hyperlinked to actually open that particular application screen and take you to the actual result. Because by ingesting the data from that source into our index is now isolated, but it's linked back to that source of record. So when you click on a result, you're actually going to be taken to that source system. It's a Siemens radiology system or MRI system or whatever it is, right? If it's a document on a file share, you click on the document, you can actually open the document. One of the other things that I kind of skipped over when I was back here on the radiology results is, again, you get to see a preview of the radiology image itself, right? If it's an imaging system, if you have multiple imaging systems, you get to see a preview of it. It's the same for documents. So if you have a preview of a document that's available it will actually show when you kind of hover over the result. I'm going to do another example. I want to find out all of the CBC tests that we've executed. So if you kind of just look at the lab names down the side here, it's anything starting with CBC. So CBC hemoglobin, there were 34. I can actually click through that one and actually go and look and see a specific CBC hemoglobin result. And so if you're doing clinical research and you want to get more in depth with it, you might do something like, I have a lab name for CBC, but a lab value between 0 and 1, right? Or you can get even more specific, a lab units of milligrams and the lab values between 0 and 0.4. So you can actually do very specific shaped queries against data, against text, right? So I can type in the name of a laboratory test or the name of a patient, and then supply it with additional information. I want this patient, this particular encounter, right, or episode or admission date, and I'd like to find out everything related to pharmacy or radiology for that patient. You can quickly, within a few seconds, search and find that patient information across multiple content sources. So hopefully that's given you a pretty good overview. I kind of want to highlight one other thing. Because the search index is a graph database, it is very high performant. So if you've noticed, even in this demo lab with only a couple thousand records in it, it compares in performance to one of our larger customers that's got 80 million items in the index, right? Or 100 million items in the index. The index is scalable, high performant. So doing these queries, you can get a result in seconds, right? In less than a second or two, typically. And all of those results are from all of the content sources because we're ingesting the data on the back end, right? So it's a scheduled ingestion of the data. It's sitting in its own data lake. So we're able to query it. If you want to do visualization, you want to do predictive analytics, you even want to do machine learning, and against that data, you can consume very large sections of this data very quickly with this platform. Let's talk about security for a minute. So healthcare organizations, right? We've got PII, PHI, right? All of the information that I've shown in this demonstration is only what I have access to. So if you log into this same application and you perform the same queries, you're going to get different results. So if your healthcare staff or clinical informatics specialist goes in and they're only given certain access levels to different patient records, right? They're only allowed to see certain kinds of patient clinical information or files. They're only going to have access to those, right? Just because it's search and everything's in the index, everything is written to the index with what they call an access control list. So every record that's written to the index also is written who's allowed to actually see the data. So this solution cannot show you all of the data because it is very secure in just kind of its core implementation. So with that, Steve, do we want to kind of check to see if there's any questions so far?
Yes, as a matter of fact, we do have some questions, Steve. So we have one here. Can you combine both documents and data into a single view?
Yeah, so that's a great question. You know, we've talked about data and documents. I think I showed an example earlier where we pulled up a specific patient. I think it's this example right here. So in this example, we're pulling data from 4 different content sources. Some of them documents, right? So images, audio, video, text documents, and some of it actually laboratory results or diagnostic information or patient data. Next question.
All right. What if the data is not formatted the same?
Oh, so we get this one all the time. I mentioned earlier a state agency. They have, I think, 30 different formats for the data that's coming in to them. They try to put down an edict and say it has to be in this particular format, right? It has to be HL7 in this version 2 or this version 3. They still have 30 different, formats. Again, our content connectors can ingest that data in any format. So we support connecting to any system in any format. And when the formats change, because they do from time to time, so the vendor does an upgrade to their software, Cerner does an upgrade to, you're on the next release and a couple of the sources have changed. It's a very quick kind of maintenance to go in and just add the additional data elements or modify the data elements that have changed.
Okay, 2 more questions here. Can you bring in data from external sources?
Yeah, again, so kind of at the top of my presentation, I talked about ingesting data from the National Institute of Health or the CDC, any data source that you have access to. So public sources of data, what they call semi-private sources. So if you subscribe to extranets, if you subscribe to medical journals and different kind of repositories, you can also connect to those repositories and ingest the data into the data lake, so that if I'm researching a patient and they have, maybe it's a rare disorder, and I've typed in that disorder name and that patient name, I'm also seeing information that may come from an external source that is an expert in that area that you've subscribed to, and that the physician or the clinicians have access to that right there kind of at their fingertips. They're seeing the actual patient data in your systems, they're seeing the text records, the lab results, and they're seeing the external source data kind of side by side.
Okay, last question. Do you touch my data?
Well, so that's the big question. And then Steve, if you want to take over the presentation again and maybe go back one slide, I want to just showcase one thing that was in that diagram with the graph database in it.
Let's see here. Whoops.
Yes. So in the graph data lake, when we ingest the data, we are making a copy of it. So we do not touch any of your sources of record. So there's an ultra low, let's call it, impact on any of your clinical information systems or any system that we're ingesting the data from, because we crawl it on a schedule in the background, and we can kind of meter that crawling aspect. And it's the freshness of the data combined with the capability of that system to be kind of crawled for its content. So once we've brought that content in to the graph data lake and the concept search rules engine kind of executes against it, that extra metadata that we're adding that gives semantic meaning, that kind of expands the data that we're ingesting and neutralizes, right, applies that consistent nomenclature of your taxonomy or your master data management rules. We don't touch the source data, just add it to the index. That index, again, very high speed. All of that extra metadata that we've added is now refinable, searchable. You can include it in your queries. You can include it in your visualizations. You can include it in your artificial intelligence, your deep learning. So again, it's a long answer. Short answer is no, we don't touch the source systems at all. but the importance of putting that metadata and the semantic meaning into the data lake is very important.
All right. Well, hey, thank you so much, Steve, for the detailed responses. And that does it for the questions. Hey, despite taking a little time for Q&A, it looks like we are going to finish a little early. So let's see here. Hopefully you gathered from a presentation today. Steve and I are relatively low-key individuals. We're certainly, would be happy to meet to engage in a, informal exploratory chat, better understand your requirements, and to discuss how we might be able to bring these benefits to your organization. And before we sign off, just want to make you aware of our next webinar, which will be happening. Actually, I believe it's the last one of the of the year. So Tuesday, November 14th, and please be sure to sign up for that. Okay, well, this concludes today's webinar. Thank you all again so much for taking time out of your day. And for those of you in the Eastern time zone, you get to start your lunch a little early. So thanks, everyone. Have a great rest of your day.